This is a circuit where a resistor and a capacitor is in series, and I feed in a DC voltage. Let's see how a capacitor works here. To understand the capacitance and the capacitor working, I have a model. Think of a resistor as a faucet. The capacitor here is a balloon, and you are trying to fill the balloon with a voltage, that is pressure. When you open the tap, the balloon will take longer to fill when the flow of water is slow. You have to wait long enough to fill the balloon completely. So the process will finish when the pressure inside the capacitance and the pressure through the water pipe is the same. Remember that I am talking about DC. So the pressure I am giving here is a DC voltage. The capacitor here acts as an infinite resistance. When I take two resistors in series, when I am feeding in 12 volt DC, so when you measure the voltage across resistance R2 will be 6 volt, and the resistance across R3 will be 6 volt. So the voltage drop across each resistor is 6 volt. So when I replace the resistor R3 with a capacitor, so the capacitor here will act as an infinite resistance. The resistance for the capacitor is infinite. So in time the capacitor will be charged up to 12 volt, and when the capacitor is charged fully, then the voltage across the resistance R1 will be 0. In practical, the capacitance is not always fully charged, but that we can take a look at it afterwards. So coming back to the circuit, here when I supply in a DC voltage, the capacitor will get fully charged. So when the voltage here, when I give in 12 volt, and the capacitor is charged up to 12 volt, so the process of charging will stop. The capacitor acts as an open in a DC circuit. So when I feed in an AC voltage, here I am feeding in an AC voltage. So I have a resistor and a capacitor. So this is an AC signal. So when the direction of the current will always keep changing. So the positive and the negative will always keep changing. So the capacitor here, which has two plates, will have positive charge and the negative charge, and it gets inverting all the time. So what the capacitor does, if I keep an LED here, it will start to discharge the voltage it acquires or it stores, and it will discharge the voltage through the LED when I keep it here, and the LED will start to glow. When I take a look at the first circuit I show you, here when I feed in a DC voltage, the capacitor acts as a open. So when I keep an LED here, nothing will happen. The charge will get accumulated here, and the capacitor will get charged, and nothing will happen to the LED here.